Okay, welcome back. We are working on continuity and intermediate value theorem, and so let's jump in. So this is just math, y'all. Here we go. So this is video 3 of 3. This is my last one. This is the intermediate value theorem. And the intermediate value theorem is somewhat intuitive. It does make a little sense, but the way it's approached, it might make you confused a little bit. Just think about it a little while. So suppose f is continuous. So we're dealing with a function that is continuous on a specific interval. It doesn't have to be continuous everywhere, just on a specific interval. And L is a number between the values of the function's endpoints, of the interval's endpoints. Then what that means is that there is a number between A and B, and we're calling that one C, that satisfies plugging it into the function, getting L. We'll come back to this red in just a minute. So let me look at a graph of this to see if it makes more sense to you. Okay, so we've got a function, and this function has to be continuous on the interval from A to B. So that means it's a function, and it's continuous. Okay, it's continuous. All right, and so f of A is a y value, and f of B, of course, is a y value. And so what they're saying is that there is some y value L in between those two that must have at least one possible point between the two. At least one. If you go back and look at it, it's got that at least one idea in there. It says there exists at least one number that when I plug in to C, I get that number. And so it's kind of like a betweenness idea. It doesn't have to be like this. It could be, it said at least one, so it could be more along the lines of, say, that, and there is at least one number between A and B that gives you the L. So it's a little bit of a betweenness type situation. So that's the intermediate value theorem. So here's an example of a real life situation that I looked at that I thought was interesting. That, a lot of students ask me, well, what do I have to get it on my final to make a grade, a specific grade? So this one made me think of intermediate value theorem. It says, suppose your before final average is a 68 and your final exam is 20% of your grade. So is it mathematically possible to make a B in the class? Okay, so your final grade is an interval. You're either going to make a 0 or you're going to make 100 or something in between. And that's your X, that's what it's going to be. And your function there is this one right here. That's your function. I want you to see how I got that function. But that's our function. Okay, and so does there exist a grade on the final that's going to give you a B? Well, if I put in 0, if I plug in 0, I'm going to make a 54. My current average is a 68, but if I plug in 0, I'm going to get 54. Okay. But if I make 100 on my final, I'm going to make a 74. Now, those of you in math, in student-wise, oh, so it's not possible to make a B. Correct. It is not possible to make a B. There is no solution for 80 in this particular thing because 80 does not fall between the endpoints of our interval. So there is no solution to this problem between 0 and 100. Now, is there a solution to this problem? Yes. We could figure out what number would it take to get an 80, but it would not be between 0 and 100. So it's not mathematically possible to make a B on this a B in this class if you start out with a 68. So that's kind of an example. It's an existence theorem. It talks about whether there exists a solution on this particular interval for this situation. Okay. Let's look at some. Let's look at some examples here. Is there a solution on the given interval? Okay, so now these are both saying equal to 0. They don't have to say equal to 0. They could say anything. But the question is there a number between 0 and 2 that I can plug in here that's going to give me 0? So what we're going to do is we're going to plug in 0 and we're going to plug in 2. So if I plug in 0, I'll plug in 0. I'm going to plug in 0 and I get 0 minus 0 minus 4. I get negative 4. And I'm going to plug in 2. And I get negative 6. So now the question is 0 between negative 6 and 4? No. So since the outcome is not between the endpoints, then there's not a number between 0 and 2 that's going to equal 0. So there's no solution to that equation on the interval from 0 to 2. Okay. All right, so now let's look at this next one. Is there an interval on this one? So we're going to plug in 0. We're going to plug in 3. We plug in 0. We get 0 minus 0 plus 0 plus 5. So when I plug in 0, I get 5. When I plug in 3, 3 is a lot more tricky. You get negative 4 times 3 squared plus 2 times the square root of 3. Okay. I had this number pulled up a little while ago. I think I wish I hadn't erased it now. I wish I hadn't erased it now. So this is going to give me negative 243. This is going to give me negative 36 plus 2 squared roots of 3 is a decimal. I had to pull out my calculator. It's 3.46 plus 5. So let's see if I can get this. I'm getting negative 270.53. Okay, so now is 0 between those two numbers? Yes, it is. 0 is between negative 270 and 5. So that means there is a solution to this problem between 0 and 3 on the interval from 0 to 3, which means from 0 to 3. So there is a solution because 0 is between the two answers. There we go. So that's the intermediate value theorem. Okay, I hope that helps. I am going to stop this video and we will start talking about 2-1 very shortly.